In this Math 30-3 linear relations video, we will be focused on creating tables of values, sorting tables, graphs, and equations as linear or nonlinear, and a review of slope.
In order to create a table of values from an equation provided, we will substitute values for x in order to determine enough y values that we could create a reasonably full-looking graph. Take this equation, for example. A reasonable set of x values to pick could be from -2 to +2. This allows us to see points near the origin and view a general trend.
When we substitute -2 for x, the equation tells us to multiply 2 by x. So multiply 2 by -2, then add 5. We'll continue substituting the values from the x column into the equation to fill out the rest of the table. If we wanted to see what this equation looked like, we could plot the points -2, 1, -1, 3, 0, 5, 1, 7, 2, 9, connect the dots and extend the line to the edges of the grid.
You can see that this graph forms a straight line, so it gets the name linear. We can tell from its table of values that it's linear since the x and y values go up or down at a constant rate. The x's go up by 1 and the y's go up by 2. These changes in x and y values are how we calculate slope, a concept we'll review at the end of this video. An equation is linear when it is of the form y equals mx plus b. This form has a number that multiplies with x and then a number that adds or subtracts from their product.
Even this is considered linear since a blank in front of x implies 1 is multiplying with x, and a blank where we could have added or subtracted indicates a 0. Let's look at an example of a nonlinear equation, table of values, and graph. We would go through the same process of substituting in x values, only this equation has a power of 2, our first indicator that it is nonlinear.
That means we'd square -2, then multiply by 2, then add 3. Following math's order of operations. Once we've filled out the table of values, you'll notice that while the x values all go up by 1, the y values go up and down by different amounts, so it's not constant and therefore non-linear.
Take a look at its graph. Is that a straight line?
No, then this graph is non-linear. So, in general, we can tell a graph is linear if all of its points lie along a straight line.
We can tell a table of values is linear if the change in x is constant and the change in y is constant.
An equation is linear if it can be written in the form y equals mx plus b.
We'll dive a little deeper into creating equations when we have graphs or tables of values in the next video. For now, let's review slope. We use the letter M for slope, and I have no idea why, but it's worth noting.
Slope often has people talking about rise over run, which is an accurate math description. But another description is the rate at which the x and y values are changing.
Take a look at the table of values we've already seen. You'll notice y values increase by 2 and x values increase by 1. As a fraction, that takes the change in y values divided by the change in x values. We see that 2 over 1 equals 2. That would be the slope of this table of values.
Had we been looking at the graph, we could also count the change in x and y values. Between each of these points, we've gone 2 up and 1 across.
We can also choose to use a formula for slope. This requires you to label 2 points' coordinates. Any 2 points along a line will work. If we pick these 2 random points, -2, 1 and 2, 9,
you may wish to label the coordinates xa, ya, and xb, yb to make substituting into the formula easier. We would subtract the y values, seeing their difference is 8, and the difference between the x values is 4. The slope is 2. Subtraction with negatives can be a pain, so we'll try to limit our examples to quadrant 1, where x and y values are positive for the sake of learning slope.
It is possible to have a negative slope, and it's also possible to have a slope that is not a whole number. Let's use this emptying hot tub to demonstrate our use of the slope formula.
If we know after 10 minutes that the hot tub has 1,630 liters in it, and that it has 340 liters left in it after 70 minutes, Then the difference in volume, 340 subtract 1,630 equals negative 1,290. And the difference in minutes is 70 subtract 10, which equals 60 minutes. Negative 1,290 divided by 60 equals negative 21.5. This slope or rate implies the water emptied the hot tub at 21.5 liters per minute.
You will notice that a negative slope will look like a line that falls as we read the graph left to right. From 1,630 to 340, we've gone down 1,290. So when we count down on a graph, that makes the change negative.